Welcome back, gang. Today we're cracking open the TEAC 80-8's logic board. Our very first recap job now that the fresh capacitors have finally arrived. And the good news, we're dealing with only 6 capacitors on this one. It makes for a great little warm-up job. And I'm going to walk you through how to mark some things out and double-check values and even photograph the board before touching a soldering iron. Of course, there's never really anything straightforward. Some of these capacitors aren't through the hole at all. Instead, their leads are just bent at right angles and soldered right to the surface of the board. So grab your seat, because we're about to breathe some new life into this control brain of the 80-8. This is the logic board from the 80-8. I'm kind of getting started here because it's only got 6 capacitors that are going to really need to be replaced. What I like to do is to take a photograph of what it is I'm going to be working on. What I like to do, identify the capacitors. The photograph doesn't really show you what the values are, so what I do is I go back and I confirm those values, and then I actually make those kinds of notations. Even though there's going to be circuitry on both sides of the board, which pretty much standard by this time, as it turns out, this particular capacitor, the leads don't go through the board. They actually are simply bent at a 90-degree angle and are soldered to the circuitry on this side of the board. And again, 9 times out of 10, the leads are going to go straight through the board. As things progressed technologically, eventually boards had circuitry on the top, the bottom, and in between. They were laminated boards, so you ended up with circuitry above, below, and in the middle. So circuitry that passed from this side to the middle ended up somewhere else entirely. Those are much more difficult to work on, if at all. But nonetheless, this is what we're going to end up doing. I'm just going to go ahead and recap these. And for those voyeurs out there who like to watch, there'll be a quiz on Tuesday. Now, this is just the first capacitor that I've taken out of this entire project. First one. Very first one. Okay, and I'm just kind of curious. Doesn't look swollen at all. It's 100 microfarad, and just curious as to what it measures. 113. Quite honestly, that's within tolerance. If that's any gauge, most of these are going to be okay. Just for grins and giggles, these are the same values. 100 microfarad at 16 volts. Old, new. It's going to be fairly obvious that capacitors have been replaced in here because the new solder is very shiny. The foil runs on the back side of this are dull. And because this board has electrical connections on the top and the bottom, I'm going to go ahead and just run a little bead of solder down on these joints here to make sure that this electrical connection is going to be equal to this electrical connection on that side. This next one is going to be slightly more problematic because although it is actually soldered on this side, there's no foil run here. The foil run is actually on this side. Let me turn it around here so you can get a better look at it. This capacitor here actually has foil runs on both sides of this circuit board. And no doubt this is probably soldered on this side as well as the other side. It's going to become necessary to be able to get underneath the replacement capacitor, once I get this one off, flow some solder onto it to make sure that there's a connection on this side. In some cases, when the boards are manufactured, they actually have a modicum of solder in certain spots, and they pass through an oven. It softens the solder, melts it, and the components are basically punched into the board. Once it cools, there's going to be solder on both the top and the bottom, and it makes that electrical connection. Thank you very much. Actually doing a manual replacement becomes more problematic, and you have to really check your work. And one way of doing that, of course, is to just use your continuity meter. Put a probe on this side and put a probe on the other side. Measure the continuity from the top and the bottom on that same solder joint. That way you know that you've got it right. And if you're wondering How am I always sure that I got the polarity of the capacitor correct? Well, I'll tell you, okay? Just a little cheat. If you look right here, before I took out the first capacitor, I went through and marked all of the negative polarity legs of each capacitor with a black dot. So that way I know that that's always negative, because sometimes, you know, you saw me pulling on the capacitor and you're desoldering it in one leg, and then you desolder in the other leg, and then finally it comes off in your hand and it gets twisted, you know, in your hand, and it's like, ooh, which way did that come out? Well, mark it first. Another thing to be mindful of is to make sure that the soldering iron is hot enough and it's heated the surface enough so that when you do pull on that component, that it's going to not still be adhered to the solder. You don't want to pull the foil run off the board because the solder cooled enough to still be attached, and yet you're applying that sort of force and end up damaging the circuit. And then, in an effort to over-explain, I want to just point out to you how the capacitor that I just took out is actually going to have some solder making contact with this circuit here on this side, nothing on this side, because all of that is on this side. This leg of the capacitor, you don't see anything on this side. This particular capacitor has got leads that are deliberately insulated, basically are soldered through the top and behind. These two connections here don't even have any circuitry on this side of the board. Everything is going to be on this side of the board. Now, even though this side of the circuit board doesn't actually have any foil runs going to the leads of the capacitor on this side, I'm going to go ahead and tack solder them in place. That way I can flip it over and actually solder the true electrical connections on the other side of the board without the capacitor shifting. And again, I'm going to have to leave some lead long enough to get the iron down in there to solder the capacitor leads on this side of the board. Oh, and the other side of the board too. That was just 6 capacitors. This is an audio card for the 80-8. This is both record and playback. There is God's own capacitors on here. Now, in looking at it, there aren't near as many circuit runs on top of the board as there is on the bottom, the underneath, the underside, the underbelly. There's close to 30 capacitors on this one board. And there's 8 of them. I'm gonna go take a nap and get ready for the next phase of this thing. And there we are, logic board recapped. And our first step on the road to restoring the TEAC 80-8 is in the bag. We learned the value of taking reference photos and double-checking capacitor values and being ready for those little surprises like the sneaky right-angle solder joints. And it's just one board. Plenty more to come in future episodes, and we'll tackle other sections step by step, plus the little gremlins that keep popping up along the way. If you're enjoying the process and maybe plotting your own recap adventure, stick around because I've got some hints for you. This machine has a lot of stories left to tell, and we're just getting started.